Could you take a look and tell me what it is? It is a dinosaur embryo inside an egg, and its computer simulation image is this. This fossil was found in China in 2021 and is named Baby Youngling. Guess how many years ago it could be? It is estimated to be 66 to 70 million years old. Titan is a giant dinosaur fossil from approximately 100 million years ago. Archaeopteryx is believed by many to be the first bird species on Earth and is approximately 150 million years old. Now, we all have more or less questions about how scientists can tell the age of any old thing, be it an Egyptian mummy, meteorite, buried tree, or furniture. Scientists have even calculated how many years ago the Earth was created. Now, by what method do scientists determine the age of fossils or the age of the Earth? I will explain this topic easily in today's video. The age of any dead or old object is measured mainly by radioactive decay. Radioactive decay is the process by which an element changes into another element by emitting radiation. These characteristics can be seen in many elements, but the most popular in determining the age of objects is C14 dating or carbon dating. We have heard about this C14 dating or carbon dating in many series and movies. The most abundant substance in our atmosphere is 78% nitrogen. Some of the nitrogen is converted into carbon under the influence of radiation from the sun. However, this carbon is slightly different from normal carbon. Normal carbon has 6 neutrons and 6 protons, which is called carbon-12. But the carbon formed from nitrogen under the effect of carbon has 6 protons and 8 neutrons, called carbon-14. The carbon-14 is unstable, and this unstable property of carbon-14 is used in determining age. Our atmosphere always maintains a certain ratio of carbon-12 to carbon-14. As a result, both these types of carbon are absorbed by plants as carbon dioxide. Later, this carbon from plants enters the bodies of humans and other animals, resulting in a balance of carbon-12 and carbon-14 in the atmosphere and in all living organisms. And this ratio is often constant over time. Now, the ratio of carbon-12 and carbon-14 in the atmosphere is 99:1. Then all living organisms will have a carbon-12 to carbon-14 ratio of 99:1. But when an organism dies, the organism does not absorb new carbon-12 or carbon-14. But as I said earlier, carbon-14 is unstable, so the decay of carbon-14 continues in the animal body even after the death of the animal. And carbon-14 decays to nitrogen. As a result, the ratio of carbon-14 and carbon-12 in the dead animal's body starts to change. The age of the dead animal can be determined by how much the ratio of carbon-12 and carbon-14 has changed. This is possible due to the decay of the radioactive element to a certain extent, which is called the half-life of the radioactive element. However, suppose an animal dies today. At the time of death, the animal had 9,900 carbon-12 in its body. Then there would be 100 carbon-14 in the ratio of 99:1. Now the radioactive decay of carbon-14 will continue even after the death of the animal. Now, the half-life of carbon-14 is 5,730 years. That is, the half-life of 100 carbon-14 means it will take 5,730 years for 50 carbon-14 to decay. But after 5,730 years from today, 50 carbon-14 will be found in the body of this dead animal instead of 100 carbon-14. But the number of carbon-12 will not change. Then the ratio of carbon-12 and carbon-14 will change from 99:1 to 198:1, and from this ratio, it can be said that the dead animal died 5,730 years ago. According to this method, if future humans get 25 carbon-14 in the body of this dead animal, then they will understand that the two half-lives of carbon-14 have been completed. The first being 100 to 50 and the second being 50 to 25. Then the age of this dead animal would be two half-lives or 11,460 years. And it is precisely in this manner that we now determine the age of dead animals or other objects. The age of the fossil is calculated by calculating the ratio of carbon-12 and carbon-14 in the environment and the ratio of carbon-12 and carbon-14 found in the fossil. For example, Mesopotamia, one of the ancient civilizations, located in modern-day Iraq, Kuwait and Syria, is considered the birthplace of civilization, whose period is about 4000 BC, which we got to know through carbon dating. Carbon-14 isotope dating was first introduced by Willard Libby in 1946. And for this contribution, in 1960, Willard Libby received the Nobel Prize. Carbon dating can be used to date objects up to 50,000 years old. But one thing should be noted here. People of the future may not be able to accurately determine the age of an object through this carbon-14 isotope. Because we are continuously burning fossil fuels and testing nuclear bombs, the ratio of carbon-12 and 14 is changing in the environment. And if this continues, in 2015, the most recent object will appear to be about 1,000 years old, which is called the switch effect. However, now the question may come to your mind. The age older than 50,000 years. It can be determined by very simple means. For example, radioactive decay is used to determine the age of objects older than 50,000 years. But in that case, isotopes of elements whose half-lives are longer than carbon are used. Potassium-argon dating is most useful thing in this case. Only 0.0117% of the total potassium found on Earth is the potassium-14 isotope. Even the half-life of this potassium-14 isotope is 1.25 billion years. As a result, it can be used to determine the age of objects that are millions of years old. Through potassium-14, 11% argon-14 and 89% calcium-14 are formed, of which argon-14 is inactive. Now imagine that lava has erupted from a volcano and formed a layer on the Earth's surface. Now the potassium-14 in the lava will decay to form argon and calcium. But since argon is an inert gas among them, it will escape in the form of bubbles. But when this lava solidifies, the argon-14 released from the potassium-14 will no longer be able to escape. That is, the argon-14 that will be produced after the lava freeze will be trapped in the rock. Now if lava comes again on this rock layer, there will be depletion of potassium and argon. But the amount of argon will be found in the lower layer compared to the upper layer. That is, the lower the rock layer goes, the more argon will increase, because there will be more argon trapped there. This will result in a different ratio of potassium to argon in different layers of the rock. To determine the age of a rock, we can calculate the ratio of potassium and argon present in it. Similarly, we can determine the age of crops by identifying the age of the layer in which a fossil is discovered. Apart from this potassium-argon dating, scientists also try different ways to determine the exact age of an object. Uranium decay, on the other hand, is used to determine the age of very old rocks. And this uranium also plays a major role in determining the age of the Earth. Now let's say how scientists have been able to determine the age of the Earth. Many people have tried to determine the age of the Earth in the past and have given a lot of information about the age of the Earth. For example, in 1778, George Louis Lacroix made some scientific calculations. He took a hot sphere modeled after the Earth and calculated its cooling time. And through this, he said at the end of his 6 years of research that the age of the Earth 75,000 years. Later, many give more strange explanations, such as James Ussher's explanation. Analyzing various books around the 16th century says that the Earth was created on October 22, 4004 BC at 6 o'clock in the evening. That is, the age of the Earth is about 6,000 years. Thus, many people give different information about the age of the Earth in many ways. But currently, we know the age of the Earth is 4.5 billion years. In determining the age of the Earth, scientists look at various aspects such as the oldest rocks found on the Earth, meteorites, etc. And in all these cases, radiometric dating is done. But in this case, the uranium-238 isotope is used, which has a half-life of 4.5 billion years. Uranium-238 decays through several steps to lead. Certain minerals play a very helpful role in determining age through this decay. One of these minerals is zircon. Zircon is usually associated with uranium but not with lead. Now if lead is found in a zircon fragment, we must understand that this lead came from the decay of uranium. This makes it possible to easily tell the age of a zircon by calculating the ratio of uranium to lead, or when the zircon was formed. The time it was made will be known. The oldest zircon ever found is 4.4 billion years old, found in Australia. Scientists then looked at rocks from the moon. Because Moon was created at the same time as the Earth was created. Now, since the Moon has no atmosphere, the Moon rocks are mostly intact. So the information that can be obtained from Moon rocks will be almost accurate. In this way, the scientists analyzed the data collected from different directions and found that all the data indicate the age of the Earth to be 4.5 billion years. Although the age as the Earth may be slightly different. In one case, you can tell the exact age with the naked eye without any research, and that is the tree. It is possible to tell the age of the tree by counting the number of rings after falling. Because the tree produces a new ring each year, the number of rings you get on a tree is the same number of years as the tree. This subject is called dendrochronology. Through this, not only the age of the tree, but also how the climate was in the past and what kind of insects were roaming around, a lot of information is known. And all this data play a very helpful role in knowing about the past of the world. To learn about the most spherical object on Earth and an important unit of mass, watch this video. And if you like the video, you can subscribe to our channel.